Good morning, all of you. So today we can discuss in the case of cubes what will be its prime factorization. Okay, we know 4 is equal to, when we factorize 4, the number 4, we will get 2 into 2. Its prime factorization we can write it as 2 into 2. And when we take its cube, when we take the cube of 4 we know that is 64. Okay, and when we take the prime factorization of 64, we will get this. How many times we multiplied 2 here? 1, 2, 3, 4, 5, 6 times. Okay, here 2 times, here 6 times. Okay, so this we will get 1 times, 3 times we will get, we can write it as 2 cube. Another set of 3 times 2, that is also 2 cube. So when we factorize the cube of a number, its prime factors appears 3 times the prime factorization of that number. Okay, here it is 2 times, here 6 times. So how many times? 3 times more. Okay, for any number when we take, and first when we write its prime factorization, and after that we take the cube of that number, then when we prime factorize that number, we will get 3 times the prime factorization of that given number. For any number we will get like that. Now take another number 6. The prime factorization of 6 we know, that is 2 into 3. Now when we consider the cube of 6 we know that is 216, and when we factorize this 216, we will get, how many times you look here? 2 appears 3 times. Here 2 appears only 1 time, and in its cube 2 appears how many times? 3 times. And also, which is the another prime factor in 6? 3. And that 3 also will appear here 1. If it is 1 times, then in its cube it will appear 3 times. So 6 is equal to 2 into 3, then 6 cube will be equal to 2 cube into 3 cube. So we can check a given number is a perfect cube or not by its prime factorization. Okay, if you get a number, and how we can check that number is a perfect cube or not? By prime factorization we can check it. So after prime factorization, if the prime factors appears as 3 times, or means appears as triples, then it will be a perfect cube. Okay, another number we can take. We want to check a number 729. A number is given, one example. It is given as number 729. We want to check the given number is a perfect cube or not. So for that we want to prime factorize that number. So when we prime factorize 729, here first 2 is not possible. So next check it for divisible by 3 or not. 9 plus 2 11, 11 plus 7 18. So it is multiple of 3. So we can divide by 3. It will be 2. Then in 12, here 2 times 2 into 3 6, then 12 4, next 3. Again, is it divisible by 3 or not? 4 plus 2 6, 6 plus 3 9. Okay, again we can divide by 3. In 24 8, in 3 1 81. Again it is possible by 3, so it will be 27. Again with 3 9. 9 by 3 we will get 3. So here we got the prime factorization of 729. We get 1 2 3 4 5 6 times 3. So 3 into how many times? 6 times 3. 1 2 3 4 5 6. Now here is it possible these prime factors as we can set as a triples. Here 1 times 1 triples. In the case of square, we make it as a pairs of prime factors. But in the case of cubes, we are making a triples of that prime factor. So here 2 times that triples prime factors we got. No other prime factors left. After this, we never get any other prime factors. So we can say this number 729 is a perfect cube. So what will be a, because no other prime factors left without, if it is suppose after prime factorization, if you got one more 3 here, suppose after prime factorization, if suppose one more 3 we will get, then what we can say, it is 1 3 is left other than these triples, so it is will not be a perfect cube. But here we got a correct triples, 2 triples we got as the prime factors, so we can say the number 729 is a perfect cube. So another number also we can check, is it prime perfect cube or not, we can check by prime factorization. Another number is given 432. The question is, check the given number 432 is a perfect cube or not. For that we will do the prime factorization of that number 432. Then first here we can divide by 2, then in 12 16, again with 2 108, 2 50, 4 2 27, 3 9 3 3. So when we factorize this, its prime factorization we got how many times? 2 1 2 3 4 times, 1 2 3 4 times, then remains 3 times 3. So now when we take the triples, here 2 1 triple we got, and for 3 also we got another triple. Now is it this number 432? Can we say this number 432 is a perfect cube? No, because after prime factorization, when we take the triples, here another 2 is left without a triples. So this number 432 is not a perfect cube. Clear? So this way we can check the given number is a perfect cube or not by prime factorization. If a number is a perfect cube, after prime factorization we will get its prime factors as triples, just like pairs in the case of squares. Clear? So I will give some homework that all of you want to do. Okay, thank you.